Welcome to Lesson 1, Matching Equations and Graphs. When we have to match an equation to an oblique graph, and as a reminder, an oblique line is a line that is slanted, not horizontal or vertical. So to do this, we will pick at least 2 points on the graph and then plug them into each equation to see which equation is satisfied by both points. So we'll do that for example 1. We have a graph on the left and we have to match that with the correct equation on the right. So we'll start by picking a couple points on the line. So here, this can be represented by the point 0, 4, and this point, which is 2, 2. So we'll start with the equation y equals 2x plus 4 and plug in 0, 4 by replacing the y value with 4 and the x value with 0. And when I simplify this, I'm trying to see if the left-hand side of the equation is equal to the right-hand side of the equation, which we do have here. 4 is equal to 4. So 0, 4 satisfies that equation. But checking just one point is not enough to match the equation. We need to check another point, so that's why we have 2, 2 picked. So y is 2 and x is 2. 2 is equal to 4 plus 4. 2 is equal to 8, which is not true. So we can say that y equals 2x plus 4 is not the correct equation. Let's look at x plus y equals 4. So x is 0 and y is 4. I do get 4 is equal to 4. So 0, 4 worked. What about 2, 2? 2 plus 2 is indeed 4. So we found the correct equation. Let's just have a look at the third equation. We'll replace x with 0 and y with 4. And that works out to be 0 plus 8, which is 8. So 0, 4 worked in this equation as well. What about 2, 2? Six plus 4 is 10. Does 10 equal 8? No. So this didn't work either. So you can see we have one point, 0, 4, that satisfied 3 different equations. So that's why picking one point is not enough to narrow down the correct equation. You do need a second point. Now here we have a slightly different example in that we have just the one equation, but we have 3 different graphs. So what we need to do when you're presented with 3 different graphs is to pick a point unique to that graph to plug into the equation. If I look at the graphs here, I have this point right here, which is on graph A and is also lies on graph C. So I want to avoid that point. I want to pick a point that is only on graph A. So this point right here, for example. So for graph A, I'm going to pick the point 3, 3. So I'm going to plug that into the equation now to see if that point satisfies the equation. So x is 3 and y is 3. 2 times 3 is 6. 3 times 3 is 9. Adding that together, I get 15. Now 15 doesn't equal 3, so graph A does not match the equation. What about graph B? So let's pick a point that is on graph B and only graph B. So we can pick this point here, which is 3, 1. So 2 times 3 plus 3 times 1. And that gives us 6 plus 3, which is 9. So 9 equals 3. No, so it's not graph B either. So let's check to make sure that it is indeed graph C. So I can pick this point right here, which is 3, negative 1. Okay, so replacing x with 3 again, and this time y with negative 1. Let's see if this works out to be 3. 6 plus negative 3 is 3. So since 3 equals 3, we have found the correct graph.